Hello students. Now the first chapter in grade 10 is number system. Before we start the chapter, you should know some of the basic concept. That is, you should know what is prime number. So let us discuss that also here. Prime numbers. The numbers which have no factors other than 1 and the number itself are called prime numbers. Then one more word we will be using. That means, say if I want to say prime numbers or prime numbers, so I will say okay, the numbers whose factors are only 1 and the number itself. That means if I take 5, so factor of 5 are 1 and 5. So it is a prime number. Now one another name we will be using, that is composite number. So now, as we know, prime factors has only two factors. So here it will be the number which have at least one factor other than 1 and the number itself are called composite numbers. So this means to say, if suppose I have taken 6, so factors of 6 are 1 and 6, 2 and 3. So at least one more factor other than the number itself and 1 it should have. So 6 is a composite number, and if I take 5 as an example, so 1 into 5, so it has only two factors. So 5 is prime number. Then one more term we will be using, that is co-prime numbers. Co-prime numbers. The set of numbers which don't have any common factor other than 1 are called co-prime numbers. So I can say example of 2 and 3. Factors of 2 are 1 and 2, 3 are 1 and 3. So leaving 1, there is nothing common in them. So they are called co-prime numbers. Now the next topic is fundamental theorem of arithmetic. It says if I take any number, I can make prime factors of that number. For example, if I take 32760, I can take out its prime factorization. So with 2 it will go 16380. Then again with 2, 8190. Again 2, 4095. Now, with 2 it is not going. So now with I will check for 3. So the technique to check for 3 is I have to total all the digits. If the digit is divisible by 3, total is divisible by 3, number is divisible by 3. So here it is divisible. So 1365 again with 3. So 455. Now it is not going with 3 as the total is not divisible by 3. Now with 5, so 591s are. Now with 7, so 13 and 13 over. So fundamental theorem of arithmetic says I can write any number in this form 2 1 2 3. So 2 cube into 3 square into 5 into 7 into 13. That means I can show any number as product of prime numbers. So that is called fundamental theorem. Now with this, one more topic is coming, that is factor tree, which is asked in the paper also, factor tree. And it's very easy and connected with this topic. That's why I have taken together only. It says, if suppose I want to make a factor tree of the same number which we have taken, so I can have two factors first, 2 into 16380. See what I am doing, the prime factorization which I have taken now, that only I am representing in tree diagram. So for making tree diagram, you need prime factorization of the number which you have taken now. So now again this if I see, so it will be 2 into 8190. Now again with 2, 4095. Now 4095, it will go with 3, 1365. Now 1365 will go with 3, so 3 and 455. And 455, 5, it will go with 5 and 91. 91 it is 7 and 13. So if you have seen carefully, all the numbers which came at the end are prime numbers. So if you are showing a prime number on the left hand side and right side the composite number, at the end all prime numbers should be there. Till that you have to go on dividing that number. The next type of question which is asked is, consider the number 4 raised to n, where n is a natural number. Check whether there is any value of n for which 4 raised to n ends with the digit 0. So the easiest way is factors of 4 are 2 into 2. Therefore 4 raised to n I can show as 2 square whole raised to n. That is 2 raised to 2n. Therefore 4 raised to n will never end with the digit 0, as to get 0 we need 2 and 5 in the factors of the number. Next type of question which is asked always is, find the HCF and LCM of 6 and 20 by prime factorization method. So here if I take out the factors of 6, I will get 2 and 3. So 6 I can write as 2 into 3. Now the second number which is given to me is 20. If I take out prime factorization, 2 tens are, 2 fives are, 5 ones are. So 20 equal to 2 into 2 into 5. So if you see carefully, 1, 2 is common. So HCF is 2, and to find LCM, whatever is common, that one time you have to write, and leaving that, all the digits you have to write which are left. So now 1, 2, 1, 3 and 1, 5 are left. So LCM will be 60. Also remember HCF of A comma B into LCM of A comma B. That is, A comma B are the numbers which are given to us, will be equal to product of the numbers, that is A into B. If I want to prove this, I can prove with this sum only. Okay, HCF of A comma B, that is HCF of 6 comma 20 was 2. So 2 into LCM 20 was 60. So 60 will be equal to the two product of two numbers, that is 6 into 20. So this side came 120, this is also 120. This formula is used to solve many of the sums asked in the paper, which we will be discussing later. Now next point is find the HCF of 96 and 404 by the prime factorization method, and hence find their LCM. So to do this, first we need to find the prime factorization of 96 and 404. So let us do that. 96 if I take and I start the prime factorization, 2 fours are 8, 1. So it's a 2, 24, 2, 12, 2, 6, and 2, 3, 3, 1. So it came 2 raised to 5 into 3. Now, if I do for 404, 2, 2, 0, 2, 2, 1, 0, 1. And now 101 is the prime number, so it came 2 square into 101. Now, to find HCF, there is a smarter way also. See, now you have to write the digit which is common. So 2 is there in both. Now the minimum power you have to write it down. So that is 2. So that will be HCF will be 4. Now if LCM by this method I want to write, I can write 2, 3 and 1013 numbers are there. So now 2's highest power is 5. So 5, 3's highest power 1, 101's 1. So this will be my LCM. Now if I want to prove by the formula HCF into LCM equal to product of two numbers. So I can use that also. See, HCF of 96 and 404 came as 4 into LCM, I don't know, equal to product of two numbers. So 96 into 404. So LCM will be 96 into 404 upon 4. So if you cut it out, you will get final answer as 9696. So that LCM you will get by both the methods. So now the exercise first question says express each of the following as a product of prime factors 140. So 140 I need to show as prime factors. So 140s, if I do prime factorization, 270s are 235, 5 and 7. So 7, 1. So I can write 2 square into 5 into 7. Same way, the second one it says 156. So now for 156, if I want to do, so 156 with 2, so 2 sevens are 1, so 8s are. Again 2, so 2 threes are 6, 1 nines are. Now 3 ones are 3 threes are, so 30. So 2 square into 3 into 30. Then third one is third one says 3825. 3825. So now let us do for 3825. So if I do the prime factorization of 3825, 8 plus 2 10, 10 plus 5 15, 15 plus 3 18. So first it will go with 3. So 3 ones are 3, 3 twos are 6, 2 remainder, 7s are 1, so 5. Now 7 plus 3 10 and 5 15. So with 3. So 4 twos are 6, 1 5s are. Now 9 10 11. So now it is not going. So with 5 5 8s are 42. So 5 5s are 5 1s are 3. So 17. So 17 1. So it will be 3 square into 5 square into 7. Now fourth one it says 5005. 5005. So see 5005. So if I do 5005, first 5 plus 5 10. So it is not going with 3, so with 5. So 1001. Now it won't go with 5, so let us try with 7. 7 ones are 7, 3s are 4s are 2. So 3s are. Now 11 13s are will be there. So this I can write 5 into 7 into 11 into 30. Then fifth one is 7429. So to do 7429, 7429. Now see last digit is 9, but if I total, see 9 plus 2 11, 11 plus 7 18, 18 plus 4 22. So it is not going with 3. So now I have to check with 7. So like that you have to go on checking till you don't get the final answer. So if I do it like that, so it will be very difficult for me. So here if I try to solve it, see, an easy way to solve it is if I cut with 17, if I cut this 7429 with 17, it will go with 17 first. So let me try with 17. So 7429 divided by 17, if I do, I am getting 437. Now 437 won't go with 17, it will go with 19. So divide by 19 if I do, I am getting 23. And 23 is also prime number. So all the three numbers are big prime numbers, 17, 19, 23. Now, question 2 says find the LCM and HCF of the following pairs of integer and verify the LCM into HCF equal to product of the two numbers. First is 26 and 91. So, if you see carefully, 26 I can write 2 into 13 and 91 if I divide it with 7, so 7 13. So, HCF will be whatever is common in both, so that is 13, and LCM will be common, you have to write one time, leaving that everything you have to write. So it is coming 182. Now, product of numbers will be 26 into 91. So that is 2366. And if I do the other side HCF into LCM, so that is 13 into 182. So that is also 2366. Hence, HCF into LCM equal to product of two numbers. Now, the B1 in that, or the second one in that, if we discuss, it says 510 and 92. So 510 and 92. So first, if I do for 510, the prime factorization, 2 twos are 4, 1, 2 fives are 10, 1 fives are. Again, 10 and 2, 12 means 3, 3 eights are 24, 1. So 5s are now 5. So 5 ones are 5, 17 and 17. So 510 comes as 2 into 3 into 5 into 17. And if I do 92, 2 fours are 8, 1, 6 are 2, 2 and 3, so 23, 1. So 2 into 2 into 23. Now common is 2, so HCF equal to 2, LCM equal to 2 into 2 into 3 into 5 into 17 into 23. So LCM will come as 23460. Now, if I do check LCM into HCF, so it will be 2 into 23460. So that will be 46920. And if I check 510 into 92, that is product of two terms. So that also will be 46920. Therefore, HCF into LCM equal to product of two numbers. Then the third one, if I do, it says 336 and 52. So 336 factor prime factors I have to find, and 52's prime factor I have to find. So 336, 2 ones are 1 remainder 6, 1 8, 284, 242, 221, 3 7. So 2 4 times, 1 time 3, 1 time 7. Now 54 if I do, 2 twos are 4, 1 sevens are 3 nines are 27. Again 3 3 3 1. So 2 into 3 cube. So if you see, HCF will be 2 into 3, that is 6, and LCM will be 2 raised to 4 into 3 cube into 7. So that will be 3024. So product of two numbers will be 336 into 52. So that is coming as 18144, and HCF into LCM 6 into 3024. So that is also coming 18144. Therefore, HCF into LCM equal to product of two numbers. Now next question says find the LCM and HCF of the following integers by applying prime factorization method. So 12 factor I can do orally, that is 4 threes are. So 4 means 2 into 2 into 3. 15 is 3 fives are. And 21 is 3 sevens are. So if you see carefully, HCF will be 3 because only 3 is common between them. LCM will be 2 square into 3 into 5 into 7. So that is coming as LCM is 2 square into 3 into 5 into 7. That is 420. Now, second one if I do, it says 17, 23 and 29. So 17 will be 1 into 17, 23 will be 1 into 23, 29 is 1 into 29 because all the three numbers are prime number. So HCF that is common in all the three is 1. LCM will be 17 into 23 into 29. So that is coming as 11339. The third one says 8, 9 and 25. So factors of 8 will be 2 into 2 into 2. 9 will be 3 into 3. 25 will be 5 into 5. So again if you see HCF is nothing common between them. That is 1. LCM will be 2 cube into 3 square into 5 square. That is. Next question says, given that HCF of 306 and 657 is 9, find LCM. So here HCF of 306, 657 equal to 9. LCM of 306, 657 equal to question mark. So I can say LCM will be equal to product of numbers upon HCF using the formula HCF into LCM equal to product of two numbers. So this will be 306 into 657 upon HCF given is 9. So the answer will be 22338. Question is check whether 6 raised to n can end with the digit 0 for any natural number n. So here I can write directly if any number ends with the digit 0, it should be divisible by 10, or in other words, it will also be divisible by 2 and 5. So prime factorization of 6 raised to n will be 2 into 3 whole raised to n, as it doesn't contains 5. Therefore 6 raised to n cannot end with the digit 0 for any natural number for any natural number n. Now next question says explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. See, now composite number means it should have more than two factors. So if I take 7 into 11 into 13 plus 13, and if from both I take 13 common, so it will be 7 into 11 plus 1, so that will be 13 into 78. Now 78 is having more than one factor, so that I can show 13 into 6. So therefore 7 into 11 into 13 plus 13 is a composite number. Now, same way, if I want to show 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So here, if I take 5 common from both, so 7 into 6 into 4 into 3 into 2 into 1 plus 1. So that will be 5 into 1008 plus 1. So that will be 5 into 1009. Again, if you see 1009 cannot be factorized further. 1009 cannot be factorized further. Therefore, 5 and 1009 are its factor. 5 and 1009 are its factor. Therefore, I can say 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. Now, next question says there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So, see, it is very clear that both are taking different time and Ravi is taking lesser time. So again they will meet when the LCM of both happens. So LCM of 18 and 12. So 18 will be equal to 2 into 3 into 3 and 12 will be 2 into 2 into 3. So LCM will be 2 square into 3 square. So that is 9 fours are 36. So therefore they will meet again at starting point after 36 minutes. Now next theorem 1.3 says root 2 is irrational. So to prove that, first let us assume that root 2 is rational. Therefore, root 2 is rational number and P and Q are co-prime numbers, co-prime integers, and q is not equal to 0. Therefore, root 2 equal to p upon q. Squaring both sides, root 2 whole square will be equal to p by q whole square. So therefore, 2q square equal to p square. Here, 2q square is a multiple of 2 and hence it is even. Thus, p square is an even number. Therefore, p is also even. So, we can assume that p equal to 2x, where x is an integer. By substituting p equal to 2x in 2q square equal to p square, therefore 2q square equal to 2x whole square. So 2q square equal to 4x square. So therefore q square equal to 4x square upon 2, which is equal to 2x square. So therefore q square is an even number. Therefore q is also even number. Since p and q both are even number, they have 2 as a common multiple, which means that p and q are not coprime and HCF is equal to 2. But this is contradiction. Therefore, root 2 is irrational number. Now, example 5 says, prove that root 3 is irrational. So, this also we are taking by the assumption method. Let us assume that root 3 is rational number. Therefore, we can find integers a and b not equal to 0 such that root 3 will be equal to a upon b. Suppose a and b have a common factor other than 1, then we can divide by common factor and assume that A and B are coprime. Therefore, B root 3 equal to A. Now squaring both sides implies B square into root 3 whole square equal to A square. So it implies 3B square equal to A square. Therefore, A square is divisible by 3, and according to theorem 1.3, A is also divisible by 3. Therefore, we can write A equal to 3C for some integer C. Substituting for A, we get 3B square equal to 3C whole square. So 3B square equal to 9C square. So therefore it implies B square will be 3C square. I have divided both sides by 3. This means that B square is divisible by 3, and so B is also divisible by 3. Therefore, A and B have at least 3 as a common factor. But this contradicts. Therefore, root 3 is irrational. Next example says, show that 5 minus root 3 is irrational. So let us assume that 5 minus root 3 is rational. Therefore, we can find A and B not equal to 0, B not equal to 0, such that 5 minus root 3 equal to A upon B. Therefore, 5 minus A upon B equal to root 3. So, therefore, root 3 equal to 5 minus A upon B. If I do LCM, I will get 5B minus A upon B. Since A and B are integers, we get 5 minus A upon B as rational. So, root 3 is rational. But this contradicts the fact that Root 3 is irrational. Therefore, 5 minus root 3 is irrational. Next question says, show that 3 root 2 is irrational. So again I will use the contradiction method. So let us assume that 3 root 2 is rational. Thus we can find A and B coprime such that B is not equal to 0. Therefore, 3 root 2 equal to A upon B. So, rearranging root 2 equal to A upon 3B. Since 3A and B are integers, A upon 3B is rational, and so root 2 is rational. But it contradicts the fact. Therefore, 3 root 2 is irrational. Now exercise 1.2 question 1 says, prove that root 5 is irrational. So this again I will take the same method. Let root 5 be rational. Therefore, it can be written in the form written as P upon Q, where Q is not equal to 0 and P and Q are coprime. Therefore, root 5 equal to P upon Q. So therefore, root 5Q equal to P. Squaring both sides, 5Q square equal to P square. P square is divided by 5. Therefore, P equal to 5C. Squaring both sides, P square equal to 25C square. Now, putting 2 in 1, equation 2 in 1, I will have 5Q square equal to 25C square. So therefore Q square will be 25 upon 5 means 5C square. Therefore Q is divisible by 5. Thus P and Q have common factor of 5, but it contradicts the fact. Therefore, root 5 is irrational. Now question 2 says prove that 3 plus 2 root 5 is irrational. So let us assume that 3 plus 2 root 5 is rational. Therefore, 3 plus 2 root 5 equal to A upon B, where A and B are co-prime and B is not equal to 0. Therefore, 2 root 5 equal to A upon B minus 3. So 2 root 5 equal to A minus 3B upon B. Therefore, root 5 equal to A minus 3B upon 2B. Here A and B are integers. So A minus 3B upon 2B is a rational number. So root 5 is also a rational number. But root 5 is irrational number. Therefore, it contradicts that 3 plus 2 root 5 is irrational. Now question 3 says, prove that the following are irrational. First one is 1 upon root 2. So let 1 upon root 2 be rational. Therefore, A upon B equal to 1 by root 2, where A and B are co-prime and B is not equal to 0. Therefore, 1 upon root 2 equal to A upon B. So B by A equal to root 2. But root 2 is irrational and B upon A is rational. As rational can't be equal to irrational, thus it contradicts. Therefore, 1 upon root 2 is irrational. Question says prove that 7 root 5 is irrational. So let us assume that 7 root 5 is rational. Therefore, 7 root 5 can be written in the form of A upon B, where A and B is not equal to 0 are co-prime. Therefore, 7 root 5 equal to A upon B. So, root 5 will be A upon 7B. But root 5 is irrational and A upon 7b is rational. Irrational can't be equal to rational. Therefore, this contradicts. Therefore, 7 root 5 is irrational. Next question says prove that 6 plus root 2 is irrational. So again, let us assume that 6 plus root 2 is rational. Thus, it can be expressed in the form P upon Q, where P and Q are co-prime and Q not equal to 0. So 6 plus root 2 equal to P upon Q. So root 2 will be equal to P upon Q minus 6. So root 2 equal to P minus 6Q upon Q, and here P, Q and minus 6 are integers. So therefore root 2 is irrational and P minus 6Q upon Q is rational, which contradicts. Therefore 6 plus root 2 is irrational.